want to acknowledge that this is an industrial facility where the product is of the utmost importance, and saving energy or saving money may not actually always be the number one goal if, for example, something's got to get produced in the way it wants to be produced. So what are some realistic, feasible examples for reducing demand that you've seen in Massachusetts facilities that still acknowledge that this is a product that's still the highest priority?
Sure. I mean, I think what you and I may have been talking about, which is probably just worth mentioning briefly, was the idea of like demand response in cannabis facilities, right? So this is when there's a particular stress on the grid that either, voluntarily or not so voluntarily, systems can be turned down in your facility to reduce grid, across the demand across the grid. What we've seen is that that's just not going to be practical in cannabis facilities because of the mission critical nature. I'm not familiar with many cultivators that are going to voluntarily reduce, light loads on their plants during critical flower stages. And similarly, any interruption of the HVAC system, it's going to overheat pretty quickly in there. So far, they appear to be an industry that is not ripe for demand response programs. But outside of that, there are some opportunities to, reduce demand. The biggest equipment-based opportunities are, LED lighting. As you can't not talk about LED lighting if you're talking about energy in cannabis. That is just the single biggest opportunity to go from that sort of standard practice of HPS to LED. Now, much of that opportunity has been taken away in Massachusetts because of the lighting power density requirements. So then that leaves HVAC opportunities, and as Keith and as Brandy have been saying, it's right sizing those systems, getting your operational conditions and parameters down, giving that to design team, right sizing your equipment. As Brendan mentioned, variable frequency drives can reduce the demand of motors so they're not, running in an on-off situation at higher loads, but are running more steady state at lower loads. And then the biggest opportunity, possibly bigger than LED, is an operational one. Facilities that run all flower rooms at the same time, which we refer to as concurrent, they incur the highest peak loads that they possibly can because they've got all their flower lights coming on at the same time. They're going to have veg lights on for some portion of that 12-hour flower photo period. You've got your HVAC systems, ramping up to full, if not close to it, to deal with that sudden spike in sensible demands and the latent that comes along with it. So you get a real peaky looking facility that has a real sharp uptick when flowering comes on, runs that way for 12 hours. Usually there'll be a dip somewhere in the middle of the day as the HVAC starts to catch up, and then the load drops off quite a bit in the later hours. You can potentially take advantage of that depending on the rate structure of your utility. Maybe you flower overnight if there's advantageous rates for that. But the operation that we've seen that's produced the best cost savings is running opposing flower room schedules or balanced flower room schedules. If you have 6 flower rooms, run 3 of them on, 3 of them off, and then switch those photo periods up. It may seem obvious, but we see a lot of existing facilities across the country that do not operate with balanced flower room schedules. And it's pretty common that I hesitate to even call them medium-sized facilities. Small to medium-sized facilities running concurrent flower rooms, we find tens of thousands of dollars just in utility rates over the course of the year if they were to move to concurrent or balanced flower rooms, or excuse me, opposing or balanced flower rooms. There are some considerations there. If you typically just work 1 shift, do you have to now work 2 shifts to cover the overnight? Can it be done with monitoring equipment? But that's a major opportunity to reduce your demand. And I think there's some HVAC sizing considerations there as well.